Let's analyze this question. There are 4 letters, 4 envelopes, and exactly one letter is to be put in exactly one envelope with the correct address. If the letters are randomly inserted to the envelopes, consider the following statement. So this question can actually be solved using the basic counting strategies as well as the logical reasoning skills. It's enough to solve the question. Okay, and let's say there are 4 letters A, B, and C. A, B, C, and D. There are 4 letters and corresponding 4 envelopes. Let's say A dash is the corresponding envelope for letter A. Then you have B dash, C dash, and D dash. Okay. Now let's take statement 1. So statement 1 is saying that it is possible that exactly one letter goes into an incorrect envelope. Exactly one. That means they're saying the statement 1 is saying that only one letter can go into an incorrect envelope. Okay, let's take an example here. Let's say letter A is going to an incorrect envelope. Let's say it's going to B dash. It is actually supposed to go to A dash, right? So letter A is going to an incorrect envelope B dash. So actually, letter B should be going to B dash, right? Right now, B should go to any one of the other envelope. So definitely we can say that more than 2 letters will go to incorrect envelope. It's a common logic, because if A is going to a different envelope, let's say B dash, so there should be a B here that is supposed to go to B dash should go to another envelope, which will be an incorrect envelope by default, right? So definitely more than one letter will definitely go to a incorrect envelope. So we can clearly say that statement 1 is not true. So option A is gone as well as option C is eliminated. Now let's analyze statement 2. So statement 2 is saying that there are only 6 ways in which only 2 letters can go into correct envelopes. There are only 6 ways. So let's take a scenario here, okay? Only 2 letters can go into the correct envelope. Let's say A and B are going to the correct envelope. So that means A is going to A dash and B is going to B dash, right? These two are going to the correct envelope. That means the other 2 letters C and D are going to the incorrect one. So C is going to D dash and D is going to C dash. It's possible. So this is one scenario, right? Where A and B is going to the correct envelope. But any 2 letters can go to actually the correct envelope. Any out of 4 letters, any 2 of them, right? So one case is AB. So just need to count how many different possible scenarios are there. Okay, case 1 is A and B are going to the correct envelope as we discussed here. It's also possible that A and C can go to the correct envelope. Also, I can say A and D, right? There are 3 cases here. Similarly, it could be B and C letters. B and C could go to the correct envelope. Or it could be B and D, right? All the letters with B and T is possible, right? Next scenario you can think about is letter C and D also is possible. Letter C and D goes to the correct envelope. So if I'm counting them, this is 1, 2, 3, 4, 5, 6. So total 6 ways are possible. So actually the second statement is actually correct. So option B has to be the right answer. You just need to use the basic logic of counting here to get the right answer. Also, you can use the permutation and combination concepts here. So statement 2 is saying that how many ways you can select 2 letters out of 4. So which is nothing but out of 4 letters, how many ways you can select 2? 4C2. So here we have listed down the different scenarios, right? Instead of that, you can always use 4C2, which is nothing but 4 times 3 divided by 2 factorial, which is 2. You can cancel it out. It's 2. 2 times 3 is equal to 6. But here in this question, you just need to list down the different possible scenarios. That is more easy. And you can definitely get the answer 6 ways. So statement 2 is true. Option B is the right answer here.